A variable is just a name that holds a value. Go gives you two ways to make one, the long way and the short way. It also has a strong opinion about which one you should be reaching for, and when. Along the way, we will meet two rules that catch every newcomer: zero values and unused variables. This is the long form, and it reads cleanly from left to right. The word var says, I am declaring a variable. Then comes the name of it, in this case, name. Then, the type. This one holds a string. And then the value we are starting it off with, Dennis. Print it, and we get, Dennis is 39. Now notice something. The type comes after the name, not before it. That is the opposite of C, or Java, or C#. Go does that on purpose, and it turns out to be more consistent once you are used to it. Most of the time, you do not need to write the type at all. Go can see that Dennis is a string, and that 39 is a whole number, so you can just leave the type out. The variables are still typed. Nothing has become loose or dynamic here. And we can prove it with %T from the last video. Dennis is a string, and 39 is an int. Go worked both of those out for itself. It just did not make us say it. And now the one you will write 9 times out of 10. : equals. It is called the short variable declaration, and it does two jobs at once. It declares the variable, and it gives it a value. No var, no type. Go infers the type from whatever you put on the right. This is what idiomatic Go looks like. Open almost any Go file, and you will see : equals everywhere. There is one restriction, and it is worth knowing now. : equals only works inside a function. Out at the top level of a file, outside every function, you have to use var. So the rule of thumb is simple. Reach for : equals almost every time. Use var when you are at the top level, or when you want a variable without giving it a value yet. Here is one of the genuinely nice things about Go. Declare a variable and give it no value at all, and Go does not leave it full of garbage the way C would. Every type has a zero value, and that is what you get. Numbers start at 0. Strings start as the empty string. Booleans start as false. Look at the output. %Q is doing useful work there. It shows us the string is 2 quote marks with nothing between them, rather than leaving us to wonder. The point is that there is no such thing as an uninitialized variable in Go. It does not exist as a concept, which is why Go code almost never asks, has this been set yet? It always has. Now a distinction that trips people up constantly. : equals declares a brand new variable. It brings it into existence. So you cannot use it twice on the same name in the same scope. Go tells you, no new variables on left side of : equals. You are not declaring anything, because score already exists. Once a variable exists, you change it with a plain equals sign. No colon. Declare once with : equals. Change it as often as you like with equals. It is a one-character difference, and the compiler will catch it every time. But it is worth understanding, rather than guessing. Remember how Go refuses to build if you import a package and never use it? It does exactly the same thing with variables. We declare x here, set it to 42, and then never touch it again. The program only prints hello. The real Go compiler refuses to build it. X declared and not used. Unlike the import rule, this is not the compiler nagging you. It kills a whole category of bugs. The variable you meant to use but did not. The typo where you assigned to the wrong name. The dead code left behind after an edit. The fix is always one of two things: use the variable or delete it. The same honest caveat as before applies. The in-browser interpreter in this course lets this one slide, so the box will run. Go build on your own machine will not. You can also declare or assign more than one variable on a single line. The first line makes x equal 3 and y equal 4. And the second line swaps them. Read it right to left. Take y and x as they are now, and put them back into x and y the other way round. So we print 4, then 3. They have traded places. Notice there is no temporary variable. In a lot of languages, you would need a third name to hold one value while you moved the other. This matters more than it looks right now. When we get to functions, you will find that Go functions routinely return two values at once, and this is how you catch them. 4 things worth keeping. Use colon equals inside functions. Use var at the top level of a file, or when you want a variable with no value yet. The type goes after the name, and most of the time you can leave it out entirely and let Go work it out. Every variable starts life at its 0 value. 0, empty string, false. There is no undefined. And declare with colon equals, but change with a plain equals. Those 4 cover essentially every variable you will write. Your turn. Declare a variable called Celsius, set to 100. Work out Fahrenheit as Celsius times 9, divided by 5, plus 32. Then print 100C equals 212F. Pause here and write it. Here is the answer. Colon equals for both, because we are inside a function, and we have values for both of them. Celsius times 9 is 900, divided by 5 is 180, plus 32 gives us 212. And %d twice, because both of those are whole numbers. One thing to note quietly here, and we will come back to it in a couple of lessons. Everything in that sum is a whole number, so Go is doing whole number arithmetic all the way through. That will matter later. That is variables in Go. 2 forms, one of which you will use almost all the time. Types that come after names, and usually go without saying. And 2 rules that feel strict for about a week, and then just feel right. Everything starts at a 0 value, and nothing sits around unused. Next up, a proper look at Go's basic types. What int really means, why float 64 is the default, and what a string is made of.